A final example and more of an application of an average value. We have a hiking trail that has an elevation given by this function, 60x cubed minus 650x squared, 1200x plus 4500, where f is the height in feet above sea level and x represents the horizontal distance along the trail in miles. All right, so basically height versus distance. Suppose the trail is 5 miles long. Find the average elevation and sketch a graph of the function and indicate the average value. All right, so this is actually a pretty easy sort of problem to set up. But first of all, we know that we're going to have our formula 1 over b minus a from a to b of f of x dx, and that's equal to our average value. Now, in this case, the trail is 5 miles long. So if we start from a terminal point, which would be 0, or initial point 0, the terminal point would be after 5 miles. And so clearly the function is given by this polynomial. And so our f bar is going to be 1 over 5 minus 0, 0 to 5 of 60x cubed minus 650x squared plus 1200x plus 4500 dx. All right. And so now we're just going to integrate term by term. Okay, so pretty easy to do this. And so if we do that, we get 1/5 of the integral. This is going to be 60 over 4 x to the 4th minus 650 over 3 x cubed, and then plus 1200 over 2x squared plus 4500x. All right, and that's going to go from 0 to 5. And at this point, we could just go ahead, substitute 5 back in. So we get 1/5 of, this is going to be 15, 5 to the 4th minus 650 over 3, 5 cubed plus 600, 5 square, and then finally plus 4500 times 5. All right, now to make this a little bit easier on us to compute, notice that we have a 1/5 and then everything inside has a factor of 5. So realistically, what we can do is we can just reduce each of these by a power of 5, all right, just to make it a little bit easier on us. And then at this point, we can just go ahead and shove it into our computer algebra system or calculator to be able to compute. All right, so make it nice and easy for ourselves by just using from alpha. And so we are going to get, let me just make sure I can see it. So this is going to be 15 times 5 to the 3rd minus 650 thirds times 5 squared plus 600 times 5 plus 4500. All right. And so we get this value 11 or 11875 over 3. All right. So that's going to be our 11875 over 3. And if we approximate that just to see what it works out to be, all right, because obviously we want to make sure that it's somewhere within the function, all right, when we plot it, that's going to work out to be 3958. So this will be 3958.333. All right. Feet. All right. And again, this would be in feet for an exact answer, but it probably would be good for us to have an approximate answer. All right. So now we have to go through and sketch a graph and then indicate the average value. All right. So again, let's go back to Wolfram Alpha. And let's just sketch the graph. And if we sketch the graph of this, this is what the function looks like. Okay, so we go up the hill and then we're rapidly going down the hill. All right. However, the average value was about 3,900. Okay, so 3958, so almost 4,000. So the average value would be right around here for the average, if you're thinking about the average height or the average elevation. So let's say, and we're going to plot 11875 over 3. And that would be y equals, and our domain is 0 to 5. All right, so let's see what that looks like. And then here is our graph of the function. All right, but then here's our average value right here. Okay, and it kind of makes sense that that would be the average value. Okay, because if we look at it, we have a lot that's going above this curve and a lot below. And remember, if we make a rectangle right here, okay, and we just think of all that area, that's going to be the area bound by the axis as well as of the function. All right, so just keeping in mind what the average value does. All right, so that's everything that we need to know about average value. So hopefully, and also arc length in this section. So just recall two formulas that we had. We had our arc length, and our arc length was equal to the integral from a to b of the square root of 1 plus f prime of x squared dx. And then we also had the average value, and that was equal to 1 over b minus a, integral from a to b of f of x dx. All right, so make sure you have these two formulas available for you on the examination, and also make sure you have them when you're doing your practice problems as well.